Welcome to Joey and Lulu's AP Stats final project, where we will be learning about the empirical rule and tree diagrams. Wouldn't it be nice to be able to find the likelihood of an event occurring without having to do much work? Well, now you can. In statistics, there is a rule that is commonly used to estimate percentages that lie under the mean in a normal distribution curve. This rule is known as the empirical rule, or the 68-95-99.7 rule. The empirical rule states that for an approximately normal distribution, nearly all of the data will fall within 3 standard deviations of the mean, as shown on this curve. The empirical rule can be broken down into 3 parts. 68% of data falls within the first standard deviation from the mean, 95% falls within 2 standard deviations, and 99.7% of the data falls within 3 standard deviations. You might be asking yourself, when do we use the empirical rule? This rule is often used in statistics to forecast, especially when obtaining the right data is difficult or impossible to get. The rule can give you a rough estimate of what your data collection might look like if you were able to survey the entire population. Now that you know the basic explanation of the empirical rule, let's put it into practice. Question 1. Grades on a statistics exam follow a normal distribution with a mean of 78 and a standard deviation of 6. Find the range around the mean that includes 95% of all the grades. As noted earlier, the empirical rule states that 95% of all data in a normal distribution falls within 2 standard deviations of the mean. By drawing the normal curve and determining these values with the standard deviation, we can say that about 95% of all the grades fall between 67 and 90%. Question number 2. The trunk diameter of a certain variety of pine tree is normally distributed with a mean of 150 centimeters and a standard deviation of 30 centimeters. Approximately what percentage of trees have a trunk diameter between 120 centimeters and 180 centimeters? For this one, we have to work backwards. First, draw the normal curve and label it with the values using your mean and standard deviation. Then, look at your normal curve. 120 and 180 centimeters fall directly on plus and minus 1 standard deviation. As stated in the empirical rule, this means that about 68% of trees have a diameter between 120 and 180 centimeters. You might be thinking, well, that was easy, and it sure was, but things get a little bit trickier, but not too tricky. This normal curve is right now divided into 3 possible percentage ranges where our data can fall. This all remains true, but we can split these percentages even more on our normal curve. We are going to show you a little bit more in these next 3 examples. Question 1. Assume the mean weight of a pineapple is 9.5 grams and the weights are normally distributed with a standard deviation of 1 gram. Without using a calculator, estimate the percentage of pineapples that weigh 8.5 grams or less. Now to do this, we need to split our curve up even more. First, use the information provided to draw the normal curve. Now, we can label the curve with more specific percentages by labeling each area individually. From -3 to +3 standard deviations, the zones are approximately 0.15%, 2.35%, 13.5%, 34%, 34%, 13.5%, 2.35%, and 0.15%. Now, to solve the problem, find 8.5 grams and add up the percentages that are contained below that value on your normal curve. And there you have it. 16% of pineapples are less than 8.5 grams. Question 2. Joey spends an average of 10 minutes on this stats project every week. It seems like he doesn't try very hard, but at least he tries. However, the amount of time he spends on the project every week is normally distributed and has a standard deviation of 1 hour. About what percentage of weeks did Joey spend at least 2 hours and 10 minutes working on the stats project? This question is similar to the one above. First, draw your normal curve with the given mean and standard deviation. Then, find the value of 2 hours and 10 minutes, or 130 minutes, on your curve, and shade in the space above it. Add up all the percentages, and you can find that Joey only spends at least 130 minutes on his stats project on 2.5% of days. He is very lazy. Question 3. Lulu eats an average of 500 oranges per day. She gets a lot of vitamin C. The amount of oranges she eats is a bit excessive, but it is still normally distributed. Wow! The standard deviation is 5 oranges. Using the empirical rule, determine the probability that she will eat between 495 and 510 oranges on a given random day. First, make your normal curve with the standard deviation and mean given. Then, find where 495 and 510 fall on the curve and shade in the area between them. They fall on -1 standard deviations and +2 standard deviations. By adding up the percentages in the shaded area, we can discover that Lulu eats between 495 and 510 oranges 81.5% of days. Now that's a lot of oranges. Now it's time for our second topic, tree diagrams and how to use them to calculate probabilities. Have you ever been staring into your closet trying to figure out what to wear and wondered how many outfits you could actually put together with your different tops, bottoms, and shoes? Tree diagrams to the rescue. Tree diagrams are a tool used that allows us to calculate the number of possible outcomes of an event, as well as list those possible outcomes in an organized manner in what is known as your sample space. Tree diagrams are used to show the combination of two or more independent events. Each branch is labeled at the end with its outcome, and the probability of each event is written alongside the line. Let's try an easy example to introduce this concept. Create a tree diagram for all the possible outcomes of flipping a coin 3 times. When flipping a coin, there are 2 possibilities, unless you have a really weird coin: heads and tails. Each has a 50% chance of occurring. For the tree diagram, your first flip has 2 options, heads and tails. The second flip can come after either a head or a tail, and then must also include both possibilities. Now there are 4 different possible combinations of heads and tails. Then, flip it one more time and you have 8 different possibilities, all branching off. There you have your first tree diagram. Let's try a more difficult example. Question 2. Joey is picking out his outfit. He has only 1 shirt, short sleeves only, 2 pairs of shorts, gray and black, and 6 hats, labeled hats 1 to 6. He doesn't wear glasses. Use a tree diagram to determine all the possible outfits that Joey can wear. Now we have a slightly different situation. Joey seems to have quite a variety of hats, but not many shirts. Very strange. To make a tree diagram, start with a shirt. There is only 1 shirt. Then Joey can choose either of the 2 pairs of shorts, gray or black. From those, he now has the option to choose 1 of 6 hats, further increasing his total outfits. As you can see, there are 12 different possibilities, all made simple by the tree diagram. Tree diagrams not only help you determine your possible sample space, but also the probability or likelihood of each event happening. That is the number we place alongside the line. First, you draw the appropriate tree diagram, assign each probability to the branches, and then multiply along individual branches to find the probability of the outcome at the end of each branch. This tree diagram helps us think through situations involving conditional probability. Tree diagrams have become very helpful for analyzing dependent events, as it allows you to show how each possible future outcome affects the probabilities of other events. Let's give it a shot. Question 3. A dog spins a spinner, throws a dart, and then eats an apple. Then the dog chooses to fight either a human or a cat. The spinner has 2 sections of equal size, red and blue. The dartboard has 3 sections of equal size, 1, 2, and 3. 3 out of 4 times the dog chooses to fight the human instead of the cat. Wow, this one is a doozy. First, we have 3 independent events: spinning a spinner, throwing a dart, and then fighting a human or a cat. Then we can start our tree diagram. The spinner has 2 equal outcomes, R and B, each with a probability of 0.5, which we draw along the line. Then we have a dartboard, which has 3 sections, 1 to 3. Branching off of R and B, we get events 1, 2, and 3 on the dartboard, each with a probability of 0.33. Finally, the dog fights either a human or a cat. This branches from all of our dartboard scenarios. The probability of fighting a human is labeled as 0.75 and the cat as 0.25, as given in the problem. Now, to find the probability of, say, spinning blue, hitting section 3 on the dartboard, and then fighting a human, you can multiply these probabilities. 0.25 times 0.33 times 0.75, which becomes 0.41, and that is called the multiplication rule. Well, that's all for today, folks, and probably all for forever. Now that we have finished this video, I hope you don't fail the AP tests, and I hope your grade goes up. Have a great day!